All right, so today we are going to jump ahead to lesson 7 of the Algebra 1, Unit 7. Remember, we're kind of jumping around here doing the absolute basics that we need to know before we move on to Unit 2. So yesterday we talked about the zero product property. And remember, with the zero product property, if a quadratic is in factored form, then we can solve it by setting each factor equal to 0 and solving for x. We did not talk about what do we do if it is not in factored form, say it's in standard form, then how do we convert it to factored form? And that's what we're going to talk about today. Two different types of factoring. So the general form is when we have an equation that looks like this, okay, in our standard form. All right, and basically we need to come up with two numbers that add up to b and multiply to c, the last number, okay? So in your lesson examples today, the first 5 of those 7 examples have to do with this first one right here. So I'm just going to go through the first 5 right now. So our first one is x squared plus 13x plus 30, and we're going to convert it to factored form. So we need to come up with two numbers that add up to b, the middle number, and multiply to c. So we need two numbers so that when I add those two numbers, I get 13. And when I multiply those two numbers, I get 30. Okay, so I need to think of two numbers that when I add them, I get 13. And when I multiply those same two numbers, I get 30. Okay, now if you have a hard time figuring out, usually what I do is I will, go ahead and write down what are numbers that multiply to 30. Well, I know 30 times 1 is 30. I know 15 times 2. I know that 10 times 3 is 30. I know that, 6 times 5 is 30. So those are all combinations of numbers that add to 30. Now, which one of those combinations adds up to 13? That's going to be what? This one right here, right? 10 plus 3 is 13, and 10 times 3 is 30. So once I figure out what those two numbers now are, 10 and 3, I automatically know that my two factors are going to be x plus 10 and x plus 3. And that is it. That is it. Okay. On number 2, again, I want to come up with two numbers that add up to the middle number. So in this case, it's 9. And those same two numbers also multiply to 20. So two numbers that when I add them, I get 9. When I multiply them, I get 20. And hopefully you realize that those two numbers are 5 and 4, right? 5 plus 4 is 9. 5 times 4 is 20. Once I figure out those two numbers, I automatically know that my two factors are x plus 5 and x plus 4. Okay. Now, somebody usually asks me, well, what happens if I write it like this? What happens if I write the answer as x plus 4, x plus 5? Would I be incorrect? And the answer to that is, of course, no. When we're multiplying, it doesn't matter the order we multiply in. So when we convert to factored form, it does not matter the order that you list those factors in. So I could have said the answer here was x plus 3, x plus 10. It wouldn't have mattered. Okay. Number 3, okay, now it's going to get a little trickier because now we're throwing negatives in there. So I'm going to do my add multiply thing. So I need to figure out two numbers that when I add them, I get -9. And when I multiply them, I get -36. So two numbers that add up to -9 and multiply to -36. Okay. So this one is kind of tricky. Okay. So if you have to list out numbers, just like I did over here, do that. Okay. But the two numbers this time are going to be -12 and +3. Okay. If you're not sure, then check and see if it works out. Is -12 plus 3 equal to -9? And the answer is yes. Is -12 times 3 equal to -36? And the answer is yes. So my factors this time, because this is negative, my first factor is going to be x minus 12 because it's negative, and my second factor is going to be x plus 3. Okay. Okay. Number 4, x squared plus x minus 12. Okay. So when I do this, now notice there's no number in the middle there, but I know when this happens that number is automatically a 1. So now I need two numbers so that when I add those two numbers, I get +1. And when I multiply those two numbers, I get -3. Okay. Or excuse me, -12. So two numbers that add up to 1, +1, and multiply to -12. Okay. And if you have to, list out different combinations, but those two numbers are going to be +4 and -3 and -3. Okay. So 4 plus -3 is equal to +1, and 4 times -3 is equal to -12. All right. So once I do that, my factors are going to be x plus 4, and my second factor is going to be x minus 3. And that is it. Okay. Last one with this one. Okay. Last one with this one. So one last time, I'm going to do my add multiply thing. So I need two numbers that add up to -11. Add up to -11 and multiply to +18. Okay. So two numbers that add to -11 multiply to +18. Well, how is that going to be possible? Well, if I know that two numbers, that when I multiply them, I get a positive number, what do I know about those two numbers? Well, if the answer to when I multiply them is positive, I know that they either both have to be positive. A positive times a positive is a positive, or they both have to be negative, because a negative times a negative is also positive. So in order for this to work, the two numbers either have to both be positive or both be negative. I can't have one of each, because a positive times a negative is a negative. Okay? So considering that they have to add up to a negative number, that means that in this case, they both have to be negative. So my two numbers are going to be -9 and -2. If you don't believe me, check and make sure it works. -9 plus -2, is that equal to -11? Yes. Is -9 times -2 equal to +18? Yes. So my two factors are x minus 9 and x minus 2. Okay. So those first 5 examples here all have to do with this part. Okay. Converting from standard form to factored form. Okay. The last 2 examples have to do with this second section here, what we call the difference of perfect squares. Now, what do I mean by perfect square? So we say that a number is a perfect square if, when I take the square root of it, I get a nice whole number. Excuse me. So, for example, 25 is a perfect square because when I square root it, the square root of 25, I get 5. Okay. 100 is another perfect square because the square root of 100 is 10. It's a whole number. But say the square root of 5, we would say that 5 is not a perfect square because when I take the square root of 5, I don't get a whole number. I get a decimal. So when I have a quadratic in which both terms are perfect squares and there's subtraction. So a difference of perfect squares with subtraction, all I need to do is take the square root of both and then create my two factors, one with positive and one with negative. Okay, I'm going to show you how that works in these last two examples here. Okay, so for number 6, I have x squared minus 9. First thing, notice there's subtraction. Okay. Second thing, notice there's two terms that have subtraction. Okay. Now, are those two terms perfect squares? Well, this second one here is easy. Is 9 a perfect square? And the answer is yes, because the square root of 9 is 3. 3 times 3 is 9. Okay. Is x squared a perfect square? In other words, is the square root of x squared a non-decimal? And the answer is yes, because the square root of x squared is x. X times x is x squared. So these are both perfect squares. Okay. So when that happens, when you have two things that are perfect squares with subtraction, all I need to do is take the square root and create my two factors. So my two factors are going to be x plus 3 and x minus 3. Okay, that's what I mean by one with plus and one with minus. Okay, and that is literally it. X plus 3 and x minus 3. Now, if I change this to x squared plus 9, I would not be able to use that shortcut. It has to be the difference of two perfect squares. So on number 7, okay, notice I have a difference, so that's promising. And if I check both of these, the square root of 25, I know is 5, because 5 times 5 is 25. How about the square root of 9x squared? Well, I know from here that the square root of x squared is x. And I also know that the square root of 9 is 3. So the square root of 9x squared is 3x. This is the difference of two perfect squares. Therefore, my two factors, I'm going to create my two factors, one with plus and one with minus. So 3x plus 5 and 3x minus 5. One with plus and one with minus. Okay? And that is literally it. Again, like I said with number 6, if this were 9x squared plus 25, I could not do it this way. I would not be able to use this difference of perfect squares shortcut. It only works if it's a difference, not a sum. So on your cool down tonight, okay, here's what your cool down is going to look like. Notice there are 6 questions here. Okay, the first four questions are going to be like these here. Okay, so I'm going to the first 4 on your cool down are going to be very similar to these here. All right, in other words, you're going to do that add multiply thing. Okay, the last 2, number 5 and number 6, you're going to do exactly like I did the last 2 examples down here. Okay. So if you get confused, go back to that section of the video or obviously ask me.